do that. Okay, here we go. There's some mornings I have to bring my daughter to orchestra, and then the earliest I could get down here is about like 7:40. But we'll just try. Okay, here we go. So today we want to talk about operations of functions, and today is definitely a day where you don't have to leave feeling confused. You can understand every part of today. Lexi, right? Lexicon? Today was golden, right? All right, great. Jeez. No. Yeah, okay, thank you. So the idea is that if we have f of x is equal to x squared, g of x is equal to x, then f plus g of x is simply x squared plus x. You just, you can add them together. Okay, so today what we're going to do is we're going to talk about function operations and, how that impacts their domains. And it gives us some tricky ways to kind of work around some of the domain issues. So in other words, if you want to do f of g of x, it's simply f of x plus g of x. If you want to do f minus g of x, it's f of x minus g of x. There's nothing really special about it. Now on Monday, we're going to talk about a different operation. You see addition, subtraction, multiplication, division. When you think of operations, that's what you think about. But we have more operations than just addition, subtraction, multiplication, division. What other operations do we have? Okay, function is something that we operate on, but operations, you're going to do something to something. What? You're going to square it, so powers, okay? We also have sine and cosine. Those are operators. We have logarithms. Those are operators. So on Monday, we're going to learn something called composition, and that's something that you operate with functions. The domain in this situation happens to be the domain of f plus, intersect, or the overlap of the domain of f and the domain of g. And it's the same thing here. The domain of f overlap with the domain of g. And same thing here. Domain of f overlap the domain of g. It's just slightly different when you get to the last one. You have to eliminate where g of x is equal to 0. Because you can't divide by 0, so we got to take that out of there. So you'll see by the first couple examples, it's really no big deal. Yo. Instead of a union, it's an intersection.
He never asks questions, so we can.
Oh, he knew the answer. He was just trying to make fun of my handwriting. It's okay. It's all right. It's okay. So today what we're going to do is, for this example, it says find f plus g, f minus g, f times g, and f divided by g in their domains. This is an IDK question I get on the test where people write IDK. There's no reason for it. You're all capable of doing it. The reason why they write IDK is they don't remember from previous years. Okay, I told you in this unit we're going to start to do something you haven't done last year. Okay, which is a nice kind of intro because if you're in calculus, every day is brand stinking new. I mean, it's never like you're like, oh, we've done this before. Yeah. F times g of x and f divided by g of x. So if I want to add them together, can you add x squared and x minus 1? Are there any terms that combine together? So I just write x squared plus x minus 1. If I subtract them, what should I do with the subtraction sign? Distribute it through. If I multiply, it's x cubed minus x squared. And f divided by g, just write x squared over x minus 1. So we've identified the functions. That wasn't too difficult, was it? Now what we need to do is identify their domains. For some of you, this is a chance to renew your understanding of domain. So if you didn't do well in this section of the last test, let's try to get it back here. Okay? X squared. What's the domain? All real numbers. X minus 1, what's the domain? All real numbers. For those of you who are asking, how do we know that? Well, the graph of x squared looks like that, and that graph is all real numbers. X minus 1 is a line, looks like that. That domain is all real numbers. Now, a lot of people look at x minus 1, they'd say, well, x can't be 1 because you can't have 0. Well, yeah, you can. 1 minus 1 is 0. That's okay. You just can't have it in the denominator. And it's not in a denominator right now. So, this states that the domain will be the overlap of the two domains. So what is the overlap of all real numbers and all real numbers? All real numbers. And it's the same for the first three. And it's even the same for the very last function, except we have to consider where the denominator is equal to 0. Denominator would be equal to 0 when x is equal to 1, so we just say x can't be 1. Question? All right. Okay, let's try B. I'm going to give myself a little bit more space because I can't write as small as you can. What happened? Okay. Okay. Oh boy. Just like, where'd that come from? All right. So, if I add these two radicals together, can you combine anything? No, their radicands are not the same. So all you do is just write the square root of 2 minus x plus the square root of x squared minus 9. F minus g, same type of thing, just subtraction sign. F times g, can I multiply the two radicals together? And when I multiply them, what do I do with what's underneath the square root sign? I just multiply them together, right? So we got to take 2 minus x times x squared minus 9. Of a 2x squared. Negative 18 plus 9x minus x cubed. Okay with that? If I divide, I could write it as one radical, so I have 2 minus x over x squared minus 9. So now I'm going to state the domain. Everybody okay with this? I need some extra space here, so I'm going to flip to a different page. Okay. As long as there's a variable involved, you can have a radical in the denominator. Okay, square root of 2 minus x. Anybody know what the domain is? Braden. Close, but not quite. If you look at the graph, it is shifted over 2 units, but it goes back this way. Yeah, the other way you could do it is you could say 2 minus x is greater than or equal to 0. Right? You can't take square root of negative. So I have negative x is greater than or equal to negative 2, so x is less than or equal to 2. So I'm talking negative infinity to positive 2. So when you consider the next function, I've take x squared minus 9 and set that greater than or equal to 0. This is a nonlinear inequality. What ways do I solve nonlinear inequalities? Make a graph. Goes right side up. So I'm wondering, where is that greater than or equal to 0? Yeah? So the domain for the new functions that we add, subtract, multiply, and divide will be the overlap of the two, the intersection. And so if I just draw a graph, that's going to give me a clear idea of what the intersection is. -3, 0, 2, and 3. So I'll draw this first one in red. I've got from 2, -infinity. I've got from -3 to -infinity, and from 3 to infinity. Yes. For my domains. So I'm now considering, where is the overlap? Do they overlap here? 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 Yeah, they overlap right there. So therefore, my domain in this scenario is from -infinity to 3, or -3. And for the last one, it's really just the same thing, but I have to consider where the denominator is equal to 0. The denominator would be equal to 0, 3, and -3. And right now, this does not include 3, but it does include -3. So what do I do? Okay, take your notes, and right now, I just want to throw a couple small pieces in there. Flip to the back side where you got some empty space. Okay. Please add in these 2 examples on the back. We just got 3 short examples left to do, and then we'll be done. It's taken me a while to realize kind of the point of this section, and so next year I'm going to redo it just a little bit, but the idea is that now we can find domain of more complex type functions. So, for example, like number 1, what if I wanted to find the domain of the square root of x plus 2 plus x plus 1? And we learned how to find the domain of the square root of x plus 2, right? But now when you add all that other stuff onto it, well, we could just use the property that we just learned in order to find that domain. It's really no big deal. I'm just going to call this one function. I'll call it g, and I'll call this another function. We'll call it h. They're just 2 functions added together, right? What's the domain of the function h? All real numbers. What's the domain of the function g? What's the overlap? So that's the domain. So, when you create 2 functions out of it, all you have to do is just find the domain of each one and then use our rule. So, look at number 2. We got x plus 2 quantity squared. We got the square root of x. On your worksheets and stuff from the last unit, we never tried to find these domains, did we? I mean, that looks difficult. We've never seen a function like that. We don't know what it looks like. But I could just call this 2 different functions. I'll call this one f. I'll call this one g. They're being multiplied together. I'll just use my property of what I know about function operations. What's the domain of a parabola? All real numbers. What's the domain of the square root of x? 0 to infinity. What's the overlap? 0 to infinity is the overlap. So can you take the square root of 0? If it was in the denominator, we would leave it off. So see how much easier that is than trying to think about what it looks like and everything? We can just simply piece it into two functions and then use our rule. That's it. Okay. Last example here. Let's do some graphical work. I was able to write it in blue and in red. You are not, so it might be just slightly more challenging for you. But what I'd like to do is some graphical addition and subtraction. It says, given the two functions, use graphical addition to sketch f plus g and f minus g. Now, I'm not given a rule here, so I got to do something just a little bit different. And it's really not that bad. You just got to make sure you're focused and then ask a question if you don't get it, because for about 2/3 of people seem to click right away. For about 1/3 of people, they had to think about it a little bit. Okay, so I want to sketch a new graph. It will just be one graph, not two. And the graph will be this thing plus this thing. So I'm going to plot a point for -6, an x value of -6. To find out what the y value is, I take the output of f and add it to the output of g. What's the output of f? What's the output of g? 4 plus -3 is 1. I'm going to do it all the way across. For every single point, every x value, I'm going to choose, I'm then going to find the y value. So now we're going to move to -5. I still have 4 and -3. When I move over to -4, what's the f value? 4, but what's the g value? So that gives me 2. Yes, Carter, it is simply just the average. You're averaging the value of the functions. I'm sketching the graph. I'm sketching the graph of if I were to add them together, what would it look like? We move to -3. I have 4 plus -1 is +3. At -2, I have 4 plus 0. At -1, I have 4 plus 1 is 5. And then at 0, I have 3 plus 1. At 1, I have 2 plus 1, 3. And how about at 2, what do I have? 1 plus 1. It's okay, Michael. We like it when you answer. 95% of the time, you're right. Yeah, no. Well, I would rather be willing to risk the wrong answer than never to answer at all. All right. 3 says 2 plus 1 is 3. And 4, I've got 3 plus 1 is 4. 5, I've got 4 plus 1 is 5. And it's going to stay there all the way across, it looks like. And so that's what f plus g looks like. So Ella's question, you're not going to see a lot of application this other than just the general understanding. There is application to calculus. We'll talk about the addition of functions. But I could see this coming up on the ACT. Here's your two graphs. which of the four choices represents the graphical addition of the two situations. And there you just add them together, you see what you get. Okay. So I'm going to have you try this one on your own. F minus G. F minus G. As you're working, I want you to know that I found some money, and we're going to order 10 pre-calculus books that are in much better shape, so we can have some that are floating around there in better condition. So if you have one at home that's in horrible shape, you want to trade it in, we could probably do that for you. So if you have something that's decent, then just work with it. So the books from 2001 doesn't look like I'm going to get new books till about 2022, somewhere around there. So just the fact is that a lot of our textbooks are online, and so it's kind of been pushed off the burner for a while. Trying to wait until the new standards come out in Minnesota and before we purchase new textbooks. I'm going to start to generate this graph so you can check. I did it before in 2 classes, so. The mistake that sometimes people make is instead of taking F minus G, they're doing G minus F. Okay, so please make sure you're doing the F minus G. So you're going to have, for example, you have 1 minus or 1 minus the 3, which will give you -2. So F minus G. If you didn't do F minus G, it will have another kind of crooked bend in there somewhere. So, all right, we good? So which you see it? Yeah. So you see that the functions switch there. Okay. I'm sorry. When I did the graphs, I wish I could have color so it'd show up better for you. So anyway, all right. So here's your assignment. You know what? If you're behind on your work, please try to make sure you're staying caught up this weekend. It's 1 through 12. My guess is that your test will be next week Friday. We just have 2 lessons to get through, and we'll be done with the content. So we don't have too much left. So when we stop this, and I'll come and help you guys.